All right, before we start working on exponential functions, in middle school you should have been introduced to at least simple interest. And that formula should look familiar. Today we're going to be talking more about compound interest. And this formula should look familiar as well. So remember, in simple interest, we'll do an example. Say you decided you wanted to take out a $2,000 loan. You had an interest rate of 5%, and you took that loan out for 4 years. So remember, you did $2,000 times the interest rate, but the rate has to be a decimal, so it'd be 0.05 times the time. And you'd work that out, and you get the interest. And then that interest was added to your actual loan that you had to pay back. Okay, we're not working on simple interest now, we're working on exponential compound interest, because it's exponential because it has the exponent here. Well, the formula is very similar, except for this A stands for the total amount, so you don't have to do any adding at the end. It's already included. Because remember, the P stands for the principal, or the starting value. The 1 stands for 100% of that starting value you're going to pay back, plus the rate, or the interest rate. And that rate has to be a decimal. And then the T stands for time. So if we take that same information and we use this formula, it looks a little bit differently. It'd be 2,000 parentheses 1 plus the rate, which remember the rate was 5%, so 0.05 to the power of 4. So you type in your calculator just like that. Remember, the exponent button with the black calculator is that button right there above the clear button. So 2,000 parentheses 1 plus 0.05 to the power of 4. And we get $2,431.01 because you round to the nearest hundredth because we're dealing with money. Okay, let's try another example. Say you take out a bigger loan, like you want to buy a car. So you would take out a $25,000 loan. And your interest rate is, say, 8%. And usually most cars you have to take out a 5 or 6 year loan. So say we're going to pay it off in 5 years. So you're using that same formula up here. Oops, I forgot the T. Go ahead and try that one. Okay, you should have gotten 25,000 parentheses 1 plus the rate, which would be 8%, so it's 0.08 to the power of 5. And that loan would be $36,753.20. So you would end up paying an additional almost $12,000 for that $25,000 loan using this compound interest. Okay, now with the handout, the formula you're going to be seeing is the general formula is y equals a times b to the power of x. The reason why it's just a general formula is because there's exponential growth and there's exponential decay. Exponential growth obviously increases, so if you were to graph it, it would look something like this. It starts out at a slower rate, and then it gets faster as time goes on. So like if you take out a loan, if you pay it off quicker, then you're not going to end up paying as much in the end, extra for it. But if you take the loan out longer, then the longer you take it out, the more it grows. Or if you invest money, same thing. The longer you let it sit, the more money you will make. Exponential decay, on the other hand, decreases. So it would look more like this, where it starts out high, but it drops quickly, and then it levels out at the end. So it's still the same concept, but the A stands for still your starting point, or starting value. The B is what we have in parentheses, and that's going to be your rate of growth or your rate of decay. And we get that by doing 1 plus the rate if it's growth, 1 minus the rate if it's the decay. So that B is really that parentheses, but then you'll see it kind of combine, and I'll show you that in just a little bit. And then your X is the same thing as the T, it's time. So here's our two examples. So I want you to read it first and think to yourself that this would be an example of growth or decay. Okay, so the keyword in there is talking about increasing at a rate of, so it would be growth. So you would use the formula. Your A is your starting point, so $15,000. That's what your loan is starting with. Times your B. Your B is your rate, so it would be 12% plus the 1. So it would be 1 plus 0.12 to the power of your time of 6. Okay, you also can combine the 1 plus 12 and just write it as 1.12 right away to get the B, because the B is actually the whole thing, 1.12. So go ahead and type that in your calculator and see what that would be. Okay, you should have gotten $29,607.34. So if you have a higher interest rate of 12%, you're paying almost double for a $15,000 loan. So hopefully you don't have that high of an interest rate. All right, the other one is on decay, because this keyword here is called depreciate. It means it goes down. You can appreciate would go up, depreciate goes down, or you might see the word decrease at a rate, but that keyword tells you it's going to be decay. So instead of adding, we're going to subtract. We're going to use this one right here. So it's still the same general formula. Your A is your starting point. Our car is worth only $15,000. Even though we paid this much, it's still only worth $15,000. So you start with $15,000, but instead of 1 plus, you're going to do 1 minus the rate, and this time the rate is 10%, so 0.10, and our time this time is 8 years. So go ahead and work that out in your calculator. And how much would the car be worth, hypothetically, if it was in perfect condition after 8 years? Okay, you should have gotten $6,457.01. Okay, the other way to write this equation is just in the form of, this one's your A, and your B would be this combined. So it would be 1 minus 0.10, so it would be 90 to the power of 8. So you might see it both ways. So if it asks, because you have to know how to write the equation, how to use the equation, and then also to identify the A and the B. So in this one, the A is 15,000, and the B is the whole thing together, 1.12. Starting point or starting value of the loan, the rate of growth here, because the loan is increasing at a rate of 0.12, so it would be 1.12. This one would be 15,000 is your A, but 0.90 would be your B, because it's decreasing its decay, so it would be rate of decay. All right, I want to do a little side idea of how to write decimals, because I talk about that on the other side. So down here at the bottom, let's just write a few examples. We already talked about 5% is 0.05. We already talked about 8% is 0.08. 12% we wrote down as 0.12. And 10% would be 0.12. 10, sorry. So remember, percent is out of 100. So you're looking for, if it's 5%, it's 500ths. 8% is 800ths. So the way you probably learned it in middle school is you move your decimal point 2 times, or you divided it as 5 over 100 as a fraction in your calculator. So you can do 5 divided by 100. you're going to get into some trickier decimals later on, like say your loan was 7.5%. The biggest mistake is writing just 7.5. That would not be correct because it's 7.5 out of 100. So your decimal would be 0.075 because your decimal point, remember, moves 2 times to the left. If it was, say, 12.5%, you would write that as 0.125. Zero in there too. You just move the decimal 2 times to the left or divide 12.5 by 100. So I just want to make sure you remember how to change your percents to decimals.